You heard earlier about flower intelligence. We need to know more, I think. It's a fantastic type of technology. It deserves a more detailed, deep dive. And I can think of no better person to tell you about flower intelligence and how it revolutionizes how you're going to serve LLMs moving forward than Flower's own Charles Beauville.
Thank you. So I will talk about flower intelligence again, going a bit more in depth compared to the keynote we had before. Perfect, it's finally working. All right, I wanted to connect the laptop so I could share a quick demo at some point in the presentation. But before we do all that, I wanted to start with just a single number. So a very large number. And this is a very gross estimate of the number of requests made to LLMs, essentially, just to run inference in a year. Some online would even use this estimate for requests made in a single day. But the gist is that it's massive and it's getting bigger and bigger. More and more people either use services directly or integrate LLM APIs into their apps. And so we can ask ourselves, how are those LLMs run? And the first, most obvious question is probably some cloud providers. So I've put some there. I think we probably all used at some point some of those providers. And the way they work is basically they have those servers, and you, the end user, you're going to send your data to the server from the provider, and then hopefully it will work and you will get some response back. And this is great. As we saw, it allows to run massive models with very quick response times because they have very beefy machines on the server side. But in many cases, this is actually not possible because you have no privacy. And in some spaces where, for instance, you have sensitive user data, or you're inside company or an organization that's not willing to share their data, this is just not feasible, and you're stuck with bad working solutions because you cannot share your data. And also, some other disadvantage is that you get actually less reliability because the server can go down. This kind of message probably already happened to some of you. And also, if you have no internet, then you can just not do anything with your model. So if you're, I don't know, in the plane or in a train, you might not be able to run your models. And so this is where local AI comes in. And so in this paradigm, the data is already on the machine. And then you also, once you have the model on the machine, you can just run. And this is beautiful because it's private. The data doesn't have to move. And also, once the model is downloaded, you can just run without any Wi-Fi or connection to the internet. So one thing that's great for local AI is that models are getting better and better. I've just added a few there to highlight the recent developments. And this is really in the span of only a month. So this is really exciting about the future, especially because on the other side, in terms of hardware, this is not very visible, but the gist is that the amount of VRAM in end-user devices is increasing exponentially year over year. So this is all very exciting for local AI. But unfortunately, there's one thing that's stopping mass adoption for local AI. And if we go back to this example of cloud AI, this is very simple. We only make a single request. We do have to share our data, but it's very simple for the device. And this can be a laptop, a phone, or even some embedded devices. And this should work without any issues. But as soon as we move to local AI, you have many steps where you first need to download the correct model that's compatible with your actual device. Then select a runtime that's also compatible, install some dependencies maybe. And the painful thing is that this might be different for each device you have. And so this can get very complicated very fast. And this is also what Daniel showed earlier. So those libraries provide amazing functionality for advanced developers, but many of the people building apps for end users don't necessarily want to care or spend a lot of time on those details instead of working on the actual functionality or the value proposition of their app. And so you also have to replicate this for each device, and there are different hardware constraints. And so we believe that this is what's really stopping local AI from getting bigger and really for the adoption to be there, because I think we see a lot of new models, some hardware coming out, but then on the software side, it's not really catching up. And this is where, if we kind of recap what we have, cloud AI is simple and device agnostic, but it's not private and not always reliable. While local AI is private, highly available, but then it's very hardware dependent and very complex to deploy. And so the main question is, what if we could have the best of both worlds? And we believe that this is what Flower Intelligence can allow us to do by providing an open source on-device AI framework with confidential remote compute. So the goal is to be fast, powerful, very simple, private, highly available, cross-platform, seamlessly integrated with existing applications, and open source. And so we believe that with our intelligence, we actually check all of those boxes. And so this is similar to the example I showed earlier during the keynote, where you can see that this is very simple, and most important, this is available for different platforms, because we believe that in order to be widely used, it needs to be able to run on apps on different devices and OSs. And so about the seamless integration that I mentioned. This is the code for cloud AI, so using OpenAI. And if we want to switch to Flower Intelligence, it's actually a single line change where we just instantiate the Flower Intelligence instance. And we don't even have to provide any API key. So just, again, this was very important to us, but because we believe that many developers might have already developed complex apps, and they might not want to change all their code base to be able to run local AI. And again, going through the list of supported models we have here, we try to have quite a few, the goal being that they're all compatible on different hardware. That was the tricky part for us. And we also, I feel like I'm doing the exact same thing, but just to show the power of local AI, here's the demo of the DeepSeek R1 685B running locally. I hope you have had time to look at it over there and play around with it. But yeah, oh, the video froze. Well, that's good, because I'm not going to show it in its entirety again. And coming to confidential remote compute, as I mentioned earlier, this is a very important feature for us because it really allows to reduce the utility frontier between existing apps and hybrid apps using local and remote. And so we want to provide a very seamless way for people to train locally when they have enough resources to do so. And once, I don't know, they consume too much RAM, for instance, instead of just shutting down or crashing, you're able to still have a successful request, but it just goes through a server fully encrypted. And this is, of course, optional because in some cases, again, even if it's encrypted, it adds some new trusted party. So this might not be possible. So this can be disabled. So it only runs locally. But then you might get some errors if you don't have enough RAM, for instance. And we really believe that this will push the adoption for more local AI and more networked AI, as Daniel mentioned before. So yeah, I just wanted to highlight the fact that this is already out. So you can already check out the different SDKs that we have open sourced. And also the documentation. So this is at flower.ai/docs/intelligence. There you will find different steps to install and then run some basic examples, guiding you through more and more complex examples. And I think this is time for me to show a little demo. So let me... All right, so I have this web page here. And this is running Flower Intelligence. Here, I'm just running Llama 3.2b, 3.23b. And I wanted to ask, who is Albert Einstein? Let's see what I get. So this is currently local. And so we'll get a response from the model, probably what you would expect from an LLM. And the beauty of this is that, so I'm currently connected to the internet, but I can actually remove my Wi-Fi, and I have no Ethernet cables. And then I can ask other questions like, he go to school. And this continues working because that's essentially the beauty of local AI. All right, I also had demo on iOS. I think we'll be a bit short on time, but feel free to come see me, and I can show you all the beautiful things we've built with Flower Intelligence. One very important thing is that if you want to actually try out the Flower Confidential Remote Compute. This is currently in closed beta, so you need to sign up to the Flower pilot program. And through this program, you can also get some support from our team, and we can help you build some amazing projects. Yeah. Last thing, but not least, I want to welcome to the stage Andre, who is part of the Thunderbolt organization.
Hey, everyone. So we started building some services recently because we noticed that a lot of our users are getting dissatisfied with big platforms like Gmail and others. And certainly part of the conversation almost immediately was LLMs. And of course, we looked at the big platforms, and we could have put an input box for ChatGPT on things and hope people used it by accident, but that really didn't seem like what was in the best interest of our users. So then we started looking at, doing our own infrastructure for deploying various AIs and LLMs, and it's a lot of work, and we discussed doing our own kind of confidential compute, doing on-device computing. For a small team trying to build several products at once, it was just more than we could handle. So partnering with Flower allowed us to focus on building our products and know that the back-end stuff was going to be handled in a way that respected user privacy. And so that's been great for us. Tomorrow there will be a talk by the lead engineer on our Thunderbird Assist project, Chris Aquino. So check that out, and I'm sure you'll find it pretty interesting. We also have our demo table over there on the left side, so if you want to see a demo of Thunderbird Assist using Flower Intelligence, please stop by over there during a break or whenever. Thank you.
Thanks a lot, Andre. And I actually have a slide about the project, but I would highly recommend instead checking out the booth that Thunderbird has over there. It's way more detailed, and you can actually try out the tool. So yeah, to recap, Flower Intelligence is an on-device AI framework with confidential remote compute. It's fully open source, and you can actually already check it out on GitHub. I would recommend also going through the docs. The Flower confidential remote compute part is currently in closed beta, but you can sign up to the pilot program to get access to it. And I'm very excited about this partnership with Thunderbird because I think that what they've built is great. So please check it out as well. Thank you.